Good morning, eighth grade science class, both in person and online. Today, we're going to be going over day 4 of the eighth grade science STAR review. This is going to be covering force, motion, and energy. So starting right off with number 1. So it says, describe the movement of a box in between the two trucks pulling on it. So you see that box in the middle, and see we have these two trucks that are pulling from it from opposite sides. We have 10 newtons going to the left and 15 newtons going to the right. So let's describe this movement. It moves to the left at increasing speed. Well, as you can see, it's going to be moving to the right because it's 5 newtons stronger to the right. Now, 10 newtons are going to cancel out 10 newtons over here. So it's only going to be moving 5 newtons to the right. All right, that's going to be your net force. All right, and plain and simple, that's 10 minus 15. 10 minus 15. And you can see that this arrow is bigger, so it's going to be moving to the right, right? Because it's 15 newtons compared to 10 newtons, okay? Make sure you always have your units, okay? So we know that A is wrong because it's not going to be moving to the left, okay? So let's mark off the other one where it says it moves to the left because it's not going to be moving to the left. All right, it moves to the right at an increasing speed, or it moves to the right at a constant speed, okay? Well, since it's going to be pulling 10 newtons over here and 50 newtons over here and a net force of 5 newtons, it's not going to be accelerating any more, all right, than 5 newtons, okay? So it's going to be moving at a constant speed, all right, which is just 5 newtons to the right. So it's not going to be increasing, it's going to be constant. Okay. Number 2, suppose you're riding a bicycle uphill and are pedaling at a constant speed. The force that you're pedaling is equal to and opposite of, okay? So that means that you're going to be riding a bike uphill, okay? You're going to be riding that bike uphill. Now remember, gravity is always working down on you, okay? And there's friction on this tire, right? There's friction between the tire and the concrete. You know that because road bikes have really thin tires and they're easier to go down the road in, while mountain bikes have really thick tires and it's harder to go down the road, but they're better for traversing like dirt. Okay, so we know that gravity is going to be a factor here. All right, but let's keep going down because this is correct, but there might be a better choice. Okay, we know that force of friction is also a factor here. So we have force and gravity over here, gravity and friction over here. So that still looks like the best choice. And then it says neither force or gravity. Well, we know that force and gravity are matching, all right, our bicycles because it's going uphill, right? So both force and gravity are either equal and opposite, okay? Good. C is our best choice. Number 3. What is the net force acting on this balloon? All right, remember, net force is just the sum and direction. So these 3 newtons to the left are going to cancel out some of these newtons to the right. So over here we have 7 newtons, okay, going to the right. And over here we have 3 newtons, okay. When you subtract the 2, you're left with 4 newtons. And you see that the arrows going to the right are greater, so it moves to the right. Okay, 4 newtons to the right. Don't use process elimination there, just a little bit of math. Okay, number 4. During a football game, a quarterback passes the ball through the air. What will happen to the ball as it travels through the air? Well, you've all played sports before. You understand when you throw a ball, what happens to it? Its speeds decrease due to air friction. Its speed will decrease due to its mass. Its speed will decrease due to the quarterback's arm. Well, I don't think anything has to do with the quarterback's arm here, right? Or it will travel at a constant speed the entire time. We know that it doesn't travel at a constant speed, right? As it leaves the quarterback's arm, it's traveling quite fast. But as it hits friction in the air, all right, it starts to slow itself down. The mass isn't changing, okay? So the speed's not going to decrease due to mass. Decrease due to mass? No, that's incorrect. Okay, that can't be right. but it will decrease due to air friction. Friction is something that slows us down, and it won't go at a constant speed, so we'll mark that one off too. Okay, so air friction is going to slow the ball down. And that's why if you throw a good spiral, all right, to your football, it's going to cut through the air better. That spiral is going to cut down on some of that air friction. It's going to go further, all right, than if you don't put a good spin on the ball, okay? All right, moving on to the next page. All right, for number 5, we see this chart here. So let's always break down the stimuli, but it's asking us, at what point does the car have an unbalanced force acting on it, okay? So we're looking for an unbalanced force. Now remember, unbalanced does not mean constant, okay? A constant force means you're balanced, you're moving at a constant speed. Unbalanced force means you're either speeding up, all right, or slowing down. So we can't use straight lines, okay? So let's go through here, break down the stimuli, okay? At 5 seconds, we're right here. And we're moving at a constant speed, okay? So that can't be it. At 15 seconds, we're right here. And again, we're not moving at all right here. As you see, no distance is changing, but time is changing. So we're not moving right here. So this is sitting still. This is constant. This is still, okay? At 25 seconds, we're going downhill, but it's still constant. You see, it's a straight line. But at 35 seconds, right here, we see a drastic change in our speed. We see a sloped line. This is not constant, right? So this is unbalanced. This is our unbalanced force. Sorry, unbalanced force, okay? Unbalanced, all right? So it's not 25, it's at 35. Number 6, which of the following scenarios is an example of an unbalanced force? So remember, unbalanced, okay, can't be constant, okay, can't be stopped, okay, and orbit is constant, guys. When you're orbiting something, you're moving at a constant speed. You know that the moon orbits around us. Does it change speed? No, we orbit around the sun. Do we change speed, the Earth? No. So this one's constant, so it can't be that one either. So a golf ball being hit with a club is the only change in speed. That ball is sitting still, and that ball is knocked out of there, okay? Moving on to number 7. You button on that for me. Appreciate it. Look at all those volunteers. Thank you, guys. All right, number 7. Sarah is investigating how the slope of an incline will affect the amount of an unbalanced force acting on a marble. So she's looking at amount of unbalanced force based on the slope of an incline. That's her experiment. Now, how will Sarah change the variable in this experiment? Well, what are the variables? She already said that she's changing or she's experimenting with the slope. That's your variable. Your marble, guys, is going to be your constant. If you change the weight of the marble and the slope, you wouldn't be able to track that. Of course, it's going to be an increase or a decrease in your unbalanced force because you're changing both. But if you keep the marble constant and change the slope, which is your variable, okay, then we're experimenting with something here. So if that's the case, what would she have to change? What variable would she need to change in the experiment? Not the marble's mass, right? Not the material, because we're not talking about friction here, guys. We're not talking about friction. That's not included. She is talking about the slope. She's definitely not talking about temperature. C is our only answer choice. Does everybody see that? They're basically just asking you what a constant or variable is, guys. Remember, variables change. Think of variable variety. It changes. You're going to change the variable in an experiment. Those are the things you're experimenting on. Your constant is what stays the same. If I was going to experiment and I was going to test loud noises in this classroom, right? And I went, I tried to see how many people heads went up, right? Now, y'all are my experiment, my variables, right? If I change my whistle every time, that would be a change in the noise, a change in the volume, right? That'd be changing something constantly. That'd be changing your constant. You can't do that, all right? Or if I was going to give some of you guys headphones and still try to run the experiment, I've messed up part of the experiment because I've given too many things, okay? Now, if you guys had headphones, that could be my control, meaning those are my students that aren't going to be affected whatsoever because they're not hearing any noise. But I'll digress. I'll move on. Number 7. All right, number 8. A rocket with a downward force of 1 newtons due to gravity and an upward force of 1 newtons. All right, explain what happening to the rocket. All right, so we have a rocket, guys. All right, this rocket is traveling upwards 1 Newton, and gravity is pulling it down at 1 Newton. Is this rocket moving? Okay. All right, so it's not launching and accelerating. Okay. It could be reaching the peak of its traveled height. Could be, right? We know it's not increasing its speed, and we know it's not accelerating. So again, we say this a billion times, you don't need to know the right answer, right? You just need to know the wrong answers. We know that it's not moving or it's at a constant or not moving. What would be another example? Maybe it was sitting on the, hadn't even launched yet, right? Because if it's pushing up with 1 newtons, right? It's not sinking into the ground, or the ground's pushing up with 1 newton. So maybe if it was saying the ground was pushing up with 1 newton and gravity was pushing down. But since it's 1 newtons up and down, constant or not moving. But we know that it's constant. Okay, so B. Good. Okay, go ahead and work on number 9, 10, 11, and 12 real quick. I want to give you guys a little bit of time here. All right, number 9. Captain Sanchez announces the passengers on his airplane are traveling 300 miles per hour, 95 degrees eastbound. He is describing the blank of the plane. Well, the 300 miles per hour, okay, is speed, but eastbound is direction. So we know it's not just speed, it's not just direction. And he's not telling the passengers if they're slowing down or increasing, right? Slowing or speeding. So that can't be it. Again, you don't have to know the correct answer. You just have to know what's wrong. But all of you guys know that velocity is just speed plus direction. Velocity is just speed plus direction. And that's what he's telling people. He's telling them how fast they're going and what direction they're headed. Number 10. Annabelle walks to school every day from her house. The diagram below shows the distance from her house to the school measured in 1 kilometer increments. If it takes her 3 minutes to walk to school, what was her average speed? Well, first thing, right off the bat, go ahead and make your speed, distance, time triangle. Speed, distance, time. Okay. And we know that because on the STAR test, you're given this, and it gives you your average speed, distance over time. And remember, you can draw okay. You're always given this on the STARS test, so you know your average speed. All right, so if we traveled a total of 1 kilometer, 1 kilometer, 1 kilometer, that's 4 kilometers total, okay? And we traveled that, that's your distance. And we traveled for 30 minutes, Okay. All right, so we can break it down here. Let's see, let's do distance over time. So 4 kilometers, but we're doing minutes here. So we need to change this 30 minutes, guys, to see how all of our units are in hours. How much is 30 minutes out of an hour? It's half, right? So 30 minutes equals 0.5 hours. Okay, so you got 4 divided by 0.5. Anybody? We know it's going to be any of these measurements here, guys. We know it's not 4 kilometers an hour because, well, that's our total distance. Okay, it's 8 kilometers an hour. 8. Right. Number 11. Samuel throws a ball into the air 20 meters. It reached the top of its flight at 2 seconds and hit the ground at 4 seconds. What was the ball's average speed on the way down? Okay, so he throws a ball up into the air. Okay. 20 meters, right? It reaches the top of its flight at 2 seconds and then falls to the ground at 4 seconds total. Okay, so how long did it take to fall? If it was 2 seconds total, guys, 2 seconds into the air, 2 seconds down, that's 4 seconds total, right? So it traveled 20 meters in 2 seconds. So 20 divided by 2 equals, good, 10 meters per second squared. Whoop. All right. Number 12, distance time graphs, guys. Remember, we talked about this earlier. If it's a straight line, it means constant. If it's a perpendicular line, perpendicular to our time, that means no movement. And if distance is greatly increasing as time constantly increases, then we know this is going to be an increase in speed. They're asking us to find a constant speed traveling away. Well, look at the distance, guys. In this situation, if this is point A and this is point B, this is you, right? Is it traveling away from you? Yeah. Distance is increasing, right? But down here, okay, this is your distance of 0 from you. As you see, it's going back to 0, right? It's going back to you. So this is moving towards you. Wow, I guess I should spell constant, right? This is moving towards you. Excuse me. Excuse me. Excuse me. Bless me. All right. So guys, which one of it is it? It's moving away from you, right? Can't be this one, guys, because this is where it's ending up. If it's ending back up at 0, all right, 0 meters, that's back where it started. Cool. All right, go ahead and turn it over real quick and complete the matching on the back, the vocabulary matching right on the back. All right, so number 1, The metric unit of measurement for distance. So find a unit for distance over here on the left, and we see meters, E. A push or pull of an object, that's force, guys, D. A push or pull. The speed and direction, so speed and direction, remember that is velocity, I. Occurs when multiple forces acting on an object cause the object to increase or decrease in speed. All right, so this is whenever you have an acceleration, a change occurs when multiple forces acting on an object cause the objects to increase or decrease in speed. Oh, actually, no, sorry. That's going to be your unbalanced force, H. The unit of measurement for time. Come over here and look for anything that measures out time, F, seconds. Occurs when multiple forces act on an object, but it doesn't cause it to move. That's going to be your balance force, B. An increase or decrease in velocity. Increase or decrease, that's going to be your acceleration, A. The distance an object travels in a certain amount of time, distance over time, guys. Distance over time, that's your speed. I believe that's G, yeah, G. And this one's hard, guys. You kind of have to think outside the box. But a line extending out from a point of reference that describes the motion of an object. If you're talking about a point of reference and where something is going, you're talking about direction, C, direction. All right, Julio. Yep, that's it for today, guys. That was the complete of day 4. Please tune in tomorrow for day 5. As always, hit that bell icon, like and subscribe. Be safe. Have a good one.